Alrighty, so for this problem, we have some ice being having energy input into it, a total amount of heat, and it brings it up to some final temperature of the water. All right, so thing is, the total heat added to the system will basically have some portion of that heat changing the ice to 0 degrees Celsius, putting it into the diffusion form where it diffuses it into water, and then also raising the water's temperature. So Q total will be the total energy input, and that's going to equal Q1 plus Q2 plus Q3. Okay, so the heat to bring the ice to a temperature where it can change into water is just going to be mass times a specific heat of ice times change in, we'll say change in T1. And then the heat of fusion will be MLF, fusion of ice to water, and this is a constant. And then to bring the water from 0 degrees Celsius to the final temperature that it says, it's going to be the mass of the water times the specific heat of the water times change in T2. So change in T1 is the initial and final temperature change of the ice. So this is like T final minus T initial, and we'll call this phase 1, we'll call this phase 2, we'll call this phase 3. And we might as well just say T3 to talk, like, let it regard phase 3. And this will basically be the final temperature of the ice will be 0, and then the initial temperature will be that negative 17 degrees, so on and so forth. So the mass of the ice going to be any different than the mass of the water? No, it's all the same mass. So we can go ahead and say that Q total is going to be mass times C change in T1 plus LF plus C water, and I'll just say CI, C water change in T2. And then the mass of the water is just going to be that total heat divided by all of that. So it's just going to be total heat divided by CI change in T1 plus LF plus specific heat of water. So go ahead and plug in all of your units and make sure that they all line up, and you should be good to go from there.